Our first talk for this session is Mariano from Instadeq, who will be presenting a live programming environment for end-user data analysis and visualization.
Okay, thank you. So yeah, Instadeq is a live programming environment for end-user data analysis and visualization. And the end result of using Instadeq is to build a reactive and responsive data visualization. Reactive because whenever the data source changes, the charts or visualizations update instantly. And responsive because the layout and the presentation adapts to the resolution of the device where the visualization is being displayed. So this is the end result. But to create it, we use the abstraction of a notebook. We call it a deck because decks have cards. Here is a deck with an empty card. When you create an empty card, you get a picker where you can select any of the available data types, card types, or you can go to example section to pick a deck example. There are many data types, card types, but we can group them in four big groups. One are sources, where they get data either from files or from external systems. And the second one is data manipulation cards, which take some inputs, do some operations, and generate some outputs. For example, group by, select, pivot, or summarize. Visual cards are cards that either take data or other cards and display them in some way. For example, charts, notes, layouts to arrange cards in a grid, collections to create lists or presentations, forms, or resources like images. And the remaining type is event cards that can generate or react to events and do operations on other cards to make them change the behavior. So the main use of Instadeq is to create a source card, configure it somehow so that you have some output. Usually it's a table like you're seeing here. If you need to aggregate it, filter, summarize it in some way, you create a data manipulation card where it has a structured query that you have to fill the placeholders with some fields from other cards. And usually you want to visualize it. So you create a visual card like a chart. And again, you have this structured query that you have to fill with data from other cards. It will allow to configure a chart based on the query structure. You can pick another one and you can play with the configuration of the chart until you are happy and you can go to the next one. So as I said, the table is the main data structure on Instadeq, but we support other two widely used data types like spreadsheets, Excel files, or Google Spreadsheets through a plugin. We provide an easy way to go from the grid that a spreadsheet is into a table. And also JSON. Here is like the tree representation of JSON. Through the input iterators, we provide ways to flatten JSON, even deep paths that require iteration, into a table. Once you have a table, most cards operate on tables, so you can go and do whatever you need. With time, we have identified common tasks that are either repetitive or error-prone, or people know what they want, but they don't know how to do them, like parsing and formatting dates and parsing and formatting numbers. So for that, we have added a tool called Magic Wand, where the user selects a column and the tool inspects the values of the column and proposes operations to be applied to that column with name and description of what's going to do, and even warnings if not all the values will be transformed correctly, and errors in case the operation cannot be applied. And this is for, well, as I said, to parsing and formatting, but also, for example, detecting numbers that may be timestamps in seconds or milliseconds, or Excel timestamps, which are a thing. And over time, we identify which are the operations that are common, and we add new tricks to the Magic Wand. This is not a black box. Each trick, when applied, will create one or more calculated fields at the top here with a formula, and the user can inspect and modify the formula if they want, or they can use it to learn how to do it if they didn't know how, and can later do it by themselves without the help of the tool. But also we have identified other tasks that require multiple steps and operation across cards, creating, configuring, and adding references to other cards. that are used a lot. The two main ones are, I have a column with names of categories, countries, cities, whatever, and I want to map them to a color. And I want to look up that color in a dictionary card that we provide. It's a way to look up from key to value for different types. And another one is I have a number and I want to map that number to a color in a range. For example, like big is bad and low is good. So a range from green to red, for example. So we have to calculate the minimum and the maximum and map it to a range. So for those tasks, we have extended the magic wand so that it can create and manipulate multiple cards in a deck. So for example, here it will create a dictionary pre-populated with the values of the column, give it colors, add the calculated field, and add it to the outputs. And here with the numeric value, it will calculate the minimum and the maximum of the column, add the field, and map it to colors. So again, when we identify common operations, we just add them so that the user can learn by basically pointing and seeing which operations are available and applying them and seeing what the application does, which changes are done. So to recap, we are using this notebook style because we have created 4 products in this area, and this is the 4th. And in the previous ones, we learned that we had like static applications with different pages where the user had to navigate back and forth. And they complained that they didn't like to have to navigate a lot to complete a task, or whenever they want to get a sense of what a chart is doing, they have to go back and forth between multiple screens to understand. So with the notebook, we try to have no modes. Basically, everything you need to do is in a single vertical linear page, and everything you need is there. You don't have to navigate back and forth. Also, we learned in previous versions where we had some pages that had like the logic visible, some others that have the data visible, and people complained that they couldn't see like the other one. And so in Instadeq, we provide collocated logic and data visible all the time. Also in our previous versions, you could like see the data by opening a pop-up window or something. Here, logic and data is always visible, collocated inside the card. Another problem in previous versions was like we had nested ownership, like a dashboard owned charts and the charts own the logic. So whenever you wanted to reuse a chart or a logic, you had to clone it. So when you made a change on one of the clones, it didn't reflect it in the other ones. So you couldn't like reuse logic. So what we did in Instadeq in this version is everything is a reference, like decks reference cards, and cards can be shared across decks. You can also clone if you want, but the default is to reference things and not clone them. Also, in previous versions, we had this static UI, and whenever we wanted to add a new feature, we identify some niche case for somebody that made sense for 10% of the users, and we wanted to add it to the tool. It would make the UI or the tool more complex and harder to understand. We like with this version that each card is kind of like a DSL, and it's self-contained. So whoever doesn't have no interest in a tool like Pivot, they can just ignore it. In the only place they are going to see it is in the picker for the empty card. And even we could hide it there via setting if we wanted. But to keep like a consistency across all the cards, we reuse the same primitives on all cards. So let's see some of the primitives. Most cards have the inputs at the top left. They are names that are used internally in the card that references data in other cards. The right side is a reference to a path into another card. And we have the structured query. It's a mix between English and SQL. And data manipulation cards have this structured query where the user has to fill the placeholders with fields. And each card does something different with the query. In this case, it's a chart. Also, we have calculated fields. They are internal fields that can depend on inputs on the card or other calculated fields. And to calculate those fields, we use a structure formula language. and that can be edited visually via what we call the formula editor, that it's an extension of like a calculator. The first section of the formula editor is the arithmetic section, which is what you would expect in a common calculator, but we extend it with different sections. Like the second one is the logic section, where we have Boolean algebra and comparison. The third one is for text strings. The next one is for functions. Then we have the record section for like maps or objects, the list section, colors, and symbols. So we extend the idea of the calculator for different data types. And the formulas are not only available on the calculated field, but wherever you need to operate on each row, a formula is available. For example, here we have a formula for the where condition of the query. Many of the queries have a where condition where you can filter input rows from the output via a condition. And we here have a formula. We also have formulas in the chart settings. Whenever a setting for a chart has to be calculated per row, we have formulas for that. So they can reuse the same knowledge and the same UI for that. At the end of most charts, we have the output section. The output section has at least one section, the default one called output, which usually is a table, but cards can have different output types. For example, there's the error type, there's the summary type. And for example, some charts have a selected section on the output that whenever somebody, for example, clicks on a bar, it will generate an output for the selected section, and somebody can drag references to these fields, and whenever the user clicks on the chart, it will generate a new output that will force the dependencies to recalculate. So here is quickly the formula editor in action. I create a new condition. I search for a function. I apply it, I focus on the parameter. I can either drop a field on the parameter or select it from the formula editor. Whenever I click, for example, on the operator, the formula editor switches to the relevant section. Here it switches to the number. I can select, focus, or drag subsections of the formula via the opening or closing parentheses. Here I add an AND condition, I add a field, I add a condition, comparison, and I edit the text on the right side. So this is a really quick way of showing, but the formula editor is pretty advanced. Like with the previous 3 versions, we have found challenges, and we are going to keep working to improve them. This one is when we linearize this like DAG, we get the problem that you have to scroll back and forth a lot to do something. And this brings the problem of long drags. When the source is far away from the target, you have to do really long drags. And for some things like formulas, we have small drop targets. So people either miss the drop or drop in the wrong place. This becomes even worse with touch devices, where your finger is on top of the thing being dragged and on top of the small target. We have features to try to alleviate all of these problems, but they are essential to like the notebook drag and drop style of things we are doing. The biggest one that we are going to be working in the near future is whenever somebody opens a deck, they don't have a way to have a high-level overview of the relationship between the cards. For that, we are exploring one of 2 alternatives. One is a panel like this on the right from a tool called Hex, which rearranges the cards in like a DAG style with arrows for references. The other one is more like Observable HQ, a minimap on the right side of the deck that has like a small visual language for dependencies between expressions and cards. We are not sure which one we are going to do. And finally, things we have learned over the years is that whenever you give power to end users to manipulate data, they are going to push the boundaries. Things we have seen, like with COVID, every day is a new data point or more data points. They ask us to lift the 100,000 rows limit to query results we have by default. People trying to drop a 90 megabyte Excel spreadsheet with 320,000 rows, or 130 megabyte JSON with 3 million data points. Somebody wanted to use Instadeq to explore an 8 gigabyte CSV with 329 columns. Somebody asking if they can use Instadeq to explore a corrupted 10 gigabyte JSON file, or somebody that has a JSON that has 11 levels deep and it breaks the layout of Instadeq. So you give it and they take it away. Implementation details, like the underlying representation is a reactive direct acyclic graph. things update whenever the output of dependency update. The view into this DAG is a notebook with decks and cards, but we can have different views if we want. Data persistence is done in two places. Like the DAG is persisted like Smalltalk style. We persist the DAG and we load it. Data usually comes from external systems. We provide something called channels where users can publish data and cards can be notified whenever a channel they are subscribed to has new data, or external systems, either push or pull. Like subscriptions are on demand. Like if the entity is active, we will subscribe, and when it becomes inactive, we will unsubscribe. Future work, we are going to create more cards. We have some ideas on pivot, the reverse of pivot, join, service, filter, time series. This high-level overview I mentioned, and try to use the same ideas for the other half, which is how to go from an exploratory SQL to publishing the results to something called headless BI, which can be consumed by tools like Instadeq to do the last mile of analytics. So thank you. And this was all.
Thanks, Mariano. We have time for 1 or 2 questions.
Okay. I will go back. So the slides are here. This is the website, and this is my Twitter account if you're interested.
Are you talking, Brian, or?
We have a question in the room.
Okay.
Hi. So you said you have a couple versions of your prototype. I'm just wondering how many users have been trying this, and on what scale of data set, and usually how long do they spend with coming up with one plot, for example, for their data set?
On our biggest instance, which is on the Ministry of Health of a European country, we have more than 700 users, of which like 5 or 10 are power users that create the dashboards, and the other ones are viewers mainly. The data usually comes from either relational databases or big data environments. So as I said, like some data sets push the 100,000 rows whenever a chart loads, and we do some processing on the front end. And in terms of people using it, this version has been running in production since last September, so more than a year. And the people that mostly use it to create right now are either people from IT, people from data science, people that know some SQL, advanced Excel users, and that's the kind of user. I don't know if I replied to your question.
Usually how long does it take for them to generate the graph?
Like for somebody with a lot of experience like me, I can create a dashboard in under 10-15 minutes, a complete dashboard, when the data is available already. For somebody else, I haven't measured, but I can expect at least like 50% more or twice as much as me, but a complete dashboard like the ones I'm showing there. If you go to our website, in the bottom, there's a link to the YouTube channel, and I have end-to-end guides where I create a complete dashboard. There you can get an idea of somebody with experience, how much they will be able to do in like 10-15 minutes.
Thanks.
Thanks so much.